Hi everybody, here's our last section. We're looking at Chapter 17, Section 3, and this is about heat and changes of state, or another way to say that is heat during phase changes. We've talked about the phase changes recently. That's, remember, sublimation and deposition, condensation and vaporization, and melting and freezing, and we're just going to look at those in more detail this time. First thing that you need to do is you need to draw a heating curve like this on your paper, and this is just a generic heating curve. It's not anything for a specific substance. But what we need to look at is we need to look at the different things on it. Like, you need to recognize that this lower section, the coldest section based on temperature here, is going to be a solid. The little flat line between solid and liquid is what's happening is melting and freezing right there. It's melting if you're moving this way from a solid to a liquid, and it's freezing if you're moving this way from a liquid to a solid. The next section that's on an incline is a liquid. So if the substance is from C to D, it's liquid. From D to E, the substance is vaporizing or condensing. If it goes from D to E, going from liquid to gas, then it's vaporizing. And if it is going from E to D, then it would be condensing. And then this last little incline, and it could go up further than that, is actually going to be the area where it's a gas. It's not uncommon for you to get images like this on the final exam and have to recognize where the states of matter are and where the phase changes are. The phase changes will always be flat lines. Notice what's happening during these time periods is that temperature over here is going to be staying exactly the same. We'll be looking at this a little bit more in class. We'll do some examples of it with like water. We're actually going to melt it and vaporize it, and we're going to see what's happening to the temperature during those times. Another thing that we have over here is the molar heat of fusion. The word molar, you should know, is referring to a mole of a substance. And heat of fusion is kind of confusing, but heat of fusion is what happens when you melt something. I don't know why they don't just say heat of melting, but they don't. They say heat of fusion, and it's on your reference table as heat of fusion. When you melt a mole of something, it requires a certain amount of heat to do that, and you can look those numbers up. Molar heat of solidification. Solidification makes a little more sense because you have the word solid in there. So that would be, molar heat of solidification would be the heat lost when a mole of a liquid solidifies or freezes. The only one of these that you'll see on your reference table is the fusion one. Basically, you're expected to understand that if you put a negative in front of that number, you would have what it takes to freeze the same substance. We're going to do some conversions with this in class, so I'm sorry, yet again, you're going to have some mole problems. You're going to have to do some conversions with that. Then you have molar heat of vaporization and condensation. Now, these make much more sense because they use words that you're familiar with. You have the molar heat of vaporization, which is how much heat you need to vaporize a mole of some liquid. And then the condensation one would be the amount of heat that is removed when you condense a mole of something. Same way, you're given the delta H vap or vaporization on your reference table. The assumption is that you know that if you put a negative in front of the same value, it would be how much heat is needed to condense it, and that should be a capital H. It's my bad. I'm just now catching that. So if it took 20 joules of heat to vaporize it, then 20 joules would need to come out to condense it back. That makes pretty good sense that it's the same amount either way. The last little thing here is heat of solution. Sometimes when you dissolve a substance, it actually can get really hot or really cold. And this isn't something that I think most people have experience with in everyday life. So I'll see if I can show you some examples of this in class. But if you have molar heat of solution, then that would just simply be how much energy is either released or absorbed. So it could go either way when a mole of a substance is dissolved. And dissolution right here is just a fancy way of saying dissolving. The dissolution of a substance is the dissolving of a substance. And, isn't this lovely? I have the same example twice. Examples, cold packs and cold packs. So we're catching some mistakes here. One example here is like the little instant cold packs. And I'll show you some examples, maybe like dissolving some sodium hydroxide in class today, that it gets pretty warm, like the temperature actually goes up as you dissolve it into solution. So we'll do some problems in class with that too. And that is the end of your notes for Chapter 17.